Hello, everybody. I'm going to give you a little bit of an insight into my world within Nike and show you a little bit of some of our product innovation and how we go through the process of creating some of the footwear that you're used to seeing. To start with, if you look into my world and you came to our campus, you would be met with this big sliding door that says, we can't let you in. And there's some text in there that says, even if you knock, we hear you, but you still can't get in. So the door's peeked open just a little bit for you today to kind of get a feel for what it's like inside. So what I did is just put together some images for you. If you came in, you'd see a range of colors and textures, new material types that we're going to be working into, our history of our deep history of our culture, sketching and concept ideation both in the hand form and then also the latest in software technologies to do that. We got to have fun, which is the frog in there. And at the same time, new materials and processes that let us create things that really the world has never seen before. So that's kind of a summary of what every day is like. And then the last image in there is really around the ability to then test and research to make sure that on the best athletes in the world, the product performs beyond expectations. So every day it's a mixture of those things, and sometimes all of them come into play, other times it's just one. But the fun thing about it is that it's always different every single day. My background is product design. I knew I wanted to do that when I was pretty much 12 years old. So I'm going to tell you now some stories around some of the products using some of these images that you've just seen. Okay? So to get started, the first one I'm going to talk to you about is the concept of biomimicry. And that is taking basically what nature has designed and then are we inspired by it to create new products. We use this constantly, so it's a tool that you learn through design school, but we've kind of refined it and honed it down to that. So for us, it's a very competitive design tool. So to start, imagine you are Asafa Powell, who, this goes back to the Beijing Olympics, one of the best track and field 100-meter sprinters in the world. When you're at that caliber, it's all about really scaring your competition and the psychology that goes around the strategy of that. He viewed himself as the cheetah, fastest animal on earth. So we looked at the cheetah and the graphics that make that animal. Every single cheetah print is a little bit different. And we studied really the circles that are on the pattern of the fur, how they get longer as the body lengthens out, so it looks like it's a fast animal. And even close up to look at the little spots that are on the top of the head, at the slowest point, the front, the spots are smaller, and they expand out as time goes through. So we had the world's greatest track spike ready to launch on the world, and you had Asafa Powell from Jamaica wanting to be able to have a graphic package that was so strong that it would be recognized around the world and scare his competition. So this is what we did. It's pretty basic when you really study it, but it takes a lot more work than that, but gives you a general idea. This is the bottom of the plate, engineered through all those steps I showed you and through our research lab to know that from a traction point of view, that was superior to anything else on the track. When he walked out on the track, this is what the person to the left and to the right saw. And that's why he won gold in Beijing. At least that's what we say. That's what we say. So that's the concept of just one track spike using graphics as a tool. And so if I tried to summarize this for you, it's studying nature. It's then, from a creative point of view, figuring out how to make that happen. Then the textiles and the process to bring that print to life on a high-performance product. And then ultimately what the product would look like. It's simple when you lay it out that way. You ready for another one? What? There you go. Okay. The next one is a story around Nike Flywire. And that product has been out for a little while now, and it's got also a very similar but simple story to it. It started out with how do we make our product lighter weight than anything in the market, in every single category that we're about. So you might find it's an interesting thing where we started. We really looked at the concept again of nature, and in this case, leaves. So this is a large leaf, and we looked at the lines that run through the leaves as veins. Very lightweight product, but the way the veins are done creates a structure to it. So a few others started to show up. This one has curves to it, and this is really one that became key It shows how the lines come inside the bowl of the leaf and then come outside. That bowl will fill with water, which is how, through rain, which is how the plant hydrates itself. So to have that amount of strength is something that we looked into to say, how do we make that work for this product? And then this one, last one, is a banana leaf, a large, large leaf, but the same thing. These veins that run through it provide the structure for the whole leaf to maintain its flat position. How do we take that and turn it into a high-performance product that's going to be the lightest product in the world? That was our challenge. As we looked at all the work that had gone on from the nature's point of view, then we looked at how man interpreted that. And this is just one image of the suspension bridge, and there's quite a few versions of these out in the world. So we saw the suspension bridge, how we interpreted for other products, and then again, nature. So our starting point was to take a typical shape of a foot and start to run string through and around that to say, where do we want support? And again, how would nature, how many strands do we need to do to make it copy what a leaf would be? And this was a starting point for that. And this was just a rough prototype that we had created. The next step was to take that concept, and then how do we start to think about manufacturing it? So these are some of our very early examples that were done through a process called embroidery. Only we changed the process quite a bit to make it much more high performance. So our next generation of sample. And then the third one came in where now we're to the point of thinking about how thin can we make those threads and how much can we bundle them together to, again, make it a high-performance product, but in the areas that we needed it. We didn't need strength everywhere, only key areas. And a summary of that was our very first prototype. This was called the Zoom Victory Spike. It was the lightest product we had ever done for track and field. So light that we were worried it would not hold up through an event like a 100-meter sprint. That was our first prototype. The final production came out looking like this. And this is what, again, was also on the track in the Beijing Olympics. So from there, we said, can we take this technology that we had started that was so appropriate for track and field and being lightweight, can we transfer it to another category? Because every single category wants to have lightweight product. So this became the Hyperdunk basketball shoe, which has been on the NBA as one of our key products. The lightest weight basketball product we've made because of the technology that we incorporated. Another one is called the Lunar Glide. It's a running shoe, but again, you can see how those fine lines have been interpreted in a little bit of a different way. And then our final product that we're showing you is the Mercurial Vapor, which is our soccer product. And then a close-up of the detail up at the top, you see how, again, we started to even emulate how nature wraps around different aspects. So again, this became a collection that we called Flywire. We're expanding the whole thing, but it started the point of how performance product become incredibly lightweight to high-end athletes and then take it down even further from there, okay? So as a summary for all of this, we took from nature. We also looked at how man had interpreted nature for other applications. From a creative point of view, how do we prototype and make something that can really work to ultimately have what we showed in this case, the basketball shoe. Good? You follow along in your little handouts? Yeah? Okay. Ready for one more? Okay. This last one is called Nike Free, and some of you have probably heard of that product. Raise your hand, you've heard about Free? Quite a few. So here's a story of that. So biomimicry is a concept. In this case, we looked at the human foot. We studied that to say, how do we make a product that performs better for the human foot? And when you really get into it, you know, there's a range of sizes that they come in, right? And what we found is people, for the most part, wish they had smaller feet, especially women. Smaller feet. And we like to have fun with them, though, too. So you always see all these wild socks and all the fun things that kids like to do with feet. So it was a little bit of a celebration of what that could be at the same time. So as we look at all this and say, how are we going to make a product that has a great innovation to it, but at the same time is rooted in some basic mechanics, that was the challenge for this. If you look at this image, this goes back to the 1984 Olympics in Los Angeles. Mary Decker Slaney is in red. Zola Budd is from South Africa in white right next to her. Do you notice anything different about Zola Budd, who's number 151? What? She doesn't have any shoes on. Both are world record holders. One has got a track spike on that grabs the surface and gives you extra propulsion. The other one does not. Who wins the race? So what ended up happening is they collided on the third lap. Mary Decker falls down. Zola Budd becomes so confused and stressed about it, she ends up finishing 7th. But we watched what was going on and go back to history to say, why did she feel she could run faster with no shoes compared to someone that had highly designed track spikes? So we see that piece. Then this is another athlete back to 1960 in the Rome Olympics. Abibi Bikila comes from Ethiopia, ran the marathon barefoot, wins. Comes back to 4 years later, wins again. Only that time he had shoes on. His village and tribe never wear feet and never wear shoes. This is what a healthy foot looks like. So you see the cracks that are in there? That's how a foot is supposed to look. So we studied all those cracks that are in that foot that are part of how it flexes and how the protection builds up over time. And then we said, you've got barefoot running that's happening, mostly on beaches, but the foot doesn't look like coming from Ethiopia. So we said, this is what a shape of a foot is like today. This is what we call a last. This is what everything is built around. It's pretty static, but that's kind of where the industry is. So in looking at how to change it, we studied the feet from the Ethiopian image that I showed you, and we started to look at all the bones and structures. The foot has 25% of all the bones in the body is in the foot. 26 of them, 36 ligaments, and 32 tendons. So there's a lot that's going on down there on the foot. So these drawings just show how we could start to now create a flex point for the foot, for the shoe, around how the foot really flexes. And that's kind of what's set up. The bottom view then is showing a side view and how those things also start to line itself up. So what came out of those rough drawings was the idea of maybe we make a shape of a foot that is totally flexible. And that's kind of what these two images show. We changed the way footwear manufacturing is done. From a manufacturing point of view, we had to figure out how to make it, which is a real challenge because we'd never made anything that would flex that way before. So we had to innovate to a new direction in terms of manufacturing, new materials that would be able to get those really fine lines that would flex and not break and fracture. And this became the first product. It was called Nike Free, and it was showing the concept of going from barefoot to a shoe, but at the same time, you got the protection you needed, but the flexibility and strength building that running barefoot would provide. And as that product evolved over time, we even got to the point where we had more flexibility that would come into the shoe. And then lastly, to what you know today to be Nike Free, looks like this. And this now is in every one of our performance categories, from running to basketball to training to soccer. So it gives you an idea where the concept of free came from. It really came from studying the human foot and how we could make it work better. So as a summary for this, again, it was a simple start of understanding the human foot, to then look at really the mechanics of how it works and understand all the geometry that makes up the mechanic of the foot, and then a new manufacturing process to ultimately be the product that you know today. Okay? Last picture for you. I've shown you a little bit about how biomimicry works from the creative process. This is the spiritual side of Nike. This is an image of Steve Prefontaine. He was Nike's very first athlete. University of Oregon track and field runner, probably the best middle distance runner the world had ever seen. Died almost 30 years ago in a car accident. His spirit is what drives the company, even today. We have a building named after him. Employees go to that building to find a way through a challenge that they're having. Very much a spiritual center of the company. So I'm balancing the passion side with Steve, with the mechanical and the design side, which I showed you with biomimicry. He has a quote that, again, drives the company. And before I show it to you, I want you, each of you, to think. You each have something very unique about yourselves, whether it's being a designer, whether it's being someone that's into literature. The whole breadth of the world is at your disposal because you have unique gifts. Some of you already know what they are. Others, it's going to take you a lifetime to find them. This is his quote. To do anything less than your best is to sacrifice your gift. Thank you.